In this video, I'm going to show you how a ROC curve is made from some basic data. So in this example, we have a problem where we're trying to predict the financial condition of a bank. We have the actual condition of the bank. We have two ratios, and we're going to use, in this case, we could be using anything, but we'll use logistic regression to be able to predict the health of these banks. And because the data set is small, just for demonstration purposes, we're not going to bother to partition the data into training and validation. And so I'm going to analyze this and going to fit the model. Because the outcome condition is a categorical variable, I put this over here in our outcome variable, and this diverts to nominal logistic, which is what we want, and we want the target level to be 1. In other words, that is a weak bank. And then we're going to take these two input variables and we're going to add those down here as things that are going to affect that. Here's the resulting ROC curve, and you can see that our area under the curve is 0.92. You can also see the resulting confusion matrix, and you can see that we have 11 that were predicted positive, and we have 9 that were predicted as negatives. In other words, we have 11 that were predicted as weak banks and 9 that were predicted as strong banks. How did this ROC curve get built? The first thing that happened was that after we estimated the regression coefficients for logistic regression, those were multiplied by the x values and added together to get legit, and then legit was turned into probability. How is that done? Pull this down, and then we can go and say what we want to do is we would like to be able to save the probabilities. And what this will do is this will create legit and the probabilities. And so we'll do that now. And here's the result. So now we have our y actual, and we have, this is legit. It just calls it ln1. And then here's our probability of this being a weak bank. And then we have the most likely predicted. So here's y actual, and here's y predicted. We can quickly sort this on the probability of 1 and come up with a probability table. So I'm going to do that. So I'm going to sort on this descending, and here it is sorted. All right, so now we have the probability sorted from the highest to the least, and you can see that here's our actuals and then here are predicteds. And we only have one of these that was predicted to be a weak bank, but according to the actual data, it doesn't look like a weak bank, but our algorithm says it is. It says it's almost, this is about a 97% probability that that is a weak bank. All right, so now what is happening here? So what's happening here is this information, and the y actual is what's being used to be able to calculate the ROC curve. Essentially, when we go down here, is this was predicted to be a 1, and it is. And so we have a true positive. This was predicted to be a 1, and it is. That's another true positive. This was predicted to be 1, and it is not. That's a false positive. And then we're back to true positives. Now let's look at our ROC curve. So I want to point out here that the confusion matrix is not driving the behavior of the ROC curve. What is really driving the behavior of the ROC curve is this probability of it being predicted to be true. So this probability, this ordered probability table, is really what is driving the behavior of the ROC curve. Well, as we start from the top, then all of these that were considered that are greater than 0.5 are predicted to be weak banks, and then everything that else is not predicted to be a weak bank. All right, and so basically what's happening is, and if you look down here, if you count this, there are 10 actual weak banks, 10 number ones, and there are 10 zeros. So we have 10 and 10, and we can see this is not balanced down here. What happens is this just works down this table and says, I predict that to be a true positive, is it? And it asks that very same question all the way down, including where the probabilities are below 0.5. So every one of these observation is going to show up as a instance in this ROC table. Let's go look, let's just kind of walk through it really fast. So basically then we have our true positive, and true positive was predicted positive, it is. So we went up 2 tenths because 2 out of 10, it went up 1/10 for each one. Then it hit its first false positive. It came over 10% of the false positives because there were 10 zeros or false positives. And then it keeps hitting true positives, and it keeps moving up here all the way until it's run out of true positives. and then it starts hitting the false positives again and just keeps marching to the right until it's out of space to the right. So essentially that's what a ROC curve does. Now, the earlier you hit a 0, a false positive, the more expensive it is. Because we hit it so early, even we hit it, just 2 stops in, and then we lost an entire 8% of our area under the curve because that was expensive to hit it early on. What if we hadn't hit our first false positive until we had hit 9 true positives, or 90% of the true positives? In this case, it would have marched over here and then just gone up, and we would have only had 1% lost area under the curve. The fact that we hit that false positive early was more expensive to our area under the curve. So that is how an area under the curve receiver operating characteristics chart is built from the data, and where you can look at the probability table and build the ROC curve.